Hello, in this video I'm going to teach you how to solve a pair of simultaneous equations using what's called the substitution method. So the way this method works is you rearrange one of the equations so it looks like x equals or y equals, and then you substitute that into the other equation and solve it to find a value of x or y. It's pretty easy, so I'll show you two examples so by the end you should have a good understanding. So let's look at this one. We've got 3x plus 4y equals 17 and x plus 3y equals 9. So I'm going to first label them equation 1 and equation 2 like this. Now it doesn't matter which equation you choose to rearrange, and it doesn't matter if you want to make it look like x equals or y equals, but usually there will be a way that looks the nicest. So for example, say I wanted to make equation 1 x equals. So how could I do that? I could subtract 4y from both sides, so I'll do it over here. So 3x is equal to 17 minus 4y, and then I'd have to divide both sides by 3, and I would get x equals 17 over 3 subtract 4 over 3y, which isn't the nicest way to do it because we're dealing with a lot of fractions. It would work, it would be possible, but there's an easier way. And the easier way would be to rearrange equation 2 to make it look like x equals, because to do that, all I have to do is subtract 3y from both sides. And if I do that, I'll get x equals 9 minus 3y. So I've rearranged it now, and I've rearranged equation 2. So now I can substitute x equals 9 minus 3y into equation 1. Okay, you have to substitute it into the other equation. And how I'm going to do that is wherever there's an x, so here, I'm going to write 9 minus 3y. So let's do it. We're going to get 3 multiplied by 9 minus 3y plus 4y equals 17. So expanding the brackets, we're going to get 3 multiplied by 9, which is 27. 3 multiplied by negative 3, which is negative 9y. And then we're going to add on 4y, and we get 17. So collecting like terms, we get 27 minus 5y equals 17. Adding 5y to both sides, that's going to give me 27 equals 17 plus 5y. Subtracting 17 from both sides is going to give me 10 is equal to 5y, and dividing both sides by 5 gives me that y is equal to 2. Now you could do a lot of those steps in one go, but I was just trying to show you every single step to rearrange to find the value of y. So now I've got a solution for y. I've got y equals 2. I need to substitute it into equation 1 or 2. It doesn't matter which one. I'll choose equation 2, so I'll substitute y equals 2 into there, and that's going to give me x plus 3 multiplied by 2 equals 9, and so x plus 6 equals 9, and therefore x is going to equal 3. And so we've solved the simultaneous equations. We've got that y is going to equal 2 and x is going to equal 3. Now if you want to check your answer, you can substitute that into either equation 1 or 2 or both and check that they satisfy, so they solve the equations, and if they do, you've done it right. So let's look at the other type of simultaneous equation you might come across, and this is where we've got an x or y squared term in the equation. So we've got x squared plus y squared equals 25 and y minus 2x equals 5. Now when we're solving equations with an x or y squared, we're going to get two solutions, okay? And the reason for that is that when I substitute something in, I'll end up with a quadratic equation which will usually have two solutions, and you'll see by the end of this example how that works. So when you're rearranging to find the value of x or y, so I'll call this equation 1 or equation 2, not always, but it's usually going to be easier to rearrange the linear equation, which is the one without an x squared in it. Because say I chose to rearrange the x squared equation in terms of y, for example, well, I'd subtract x squared from both sides and get y squared equals 25 subtract x squared. And then I'd take the square root of both sides, which would give me y equals the square root of 25 minus x squared. Now, the problem with this is it just looks more confusing when I substitute it into equation 2 than the alternative, okay, which is going to be, I'm going to rearrange equation 2 to make y the subject. So let's do that. So we're going to get y equals 5 plus 2x, and I've rearranged equation 2, so I'm going to substitute 5 plus 2x wherever there's a y in equation 1. So let's do it. We're going to get x squared plus 5 plus 2x all squared equals 25, and expanding this bracket here, I'll do it over here just so you can clearly see how we're doing it. So we've got 5 plus 2x multiplied by 5 plus 2x, and so we get 5 multiplied by 5, which is 25, 5 multiplied by 2x, which is 10x, 2x multiplied by 5, which is 10x, and 2x multiplied by 2x, which is 4x squared. And collecting like terms, we're going to get 4x squared plus 20x plus 25. So substituting that in for that 5 plus 2x all squared, we're going to get x squared plus 4x squared plus 20x plus 25 equals 25. Subtracting 25 from both sides, well, these two are going to disappear. And collecting like terms, we get 5x squared plus 20x equals 0. And now you can see I've got a quadratic equation that I can solve. So by factorising out 5x, I'm going to get 5x multiplied by x plus 4. And so because I've got two things multiplied together to give me 0, one of them has to equal 0. So either 5x is going to equal 0, or x plus 4 will equal 0. And solving these, we get that x equals 0, or x equals negative 4. So we found our two solutions for x, which is what we wanted. And now to find these solutions for y, I substitute them both in for y one at a time. So what I mean by that, I didn't say that very well, but what I mean is we'll do x equals 0 first, and I'll substitute that into equation 1 or 2. I'll choose equation 2 because it's nicer, because it's linear. So that is y minus 2x equals 5. So substituting x equals 0 into there, we get y equals 5. So y equals 5 is my solution when x equals 0. Or, okay, now I'm going to substitute in, x equals negative 4. And if I do that, we get y subtract 2 times negative 4 equals 5. And so y plus 8 equals 5. And therefore y equals negative 3. So we get the other solution for y. And there we go. We've got our 4 solutions for x and y, which solve the simultaneous equations. Hopefully it was useful. If it was, subscribe to my channel and check out all my other videos, past papers, tutorials, stuff like that. And you can go over to my TikTok, link in my description, where there's loads of other worked exam questions. Thanks for watching.